On this one, we've got a couple points, and we want to find the point on this line y equals 2 that makes the total distance from A to whatever point we find on the line back up to P, back up to B as small as possible. And so, generally speaking, what we're talking about is there's some point on here. This is y equals 2. There's some point on here where if I started here, went and touched a line, and went back up, it's going to be the shortest distance. So we're trying to find this point. I'm just going to generally mark an area. This isn't necessarily where this is, but this is point P, and we're going to go from here down, and then from here up, and we want the shortest distance possible. So as we slide P over, it's going to change that distance that we travel of the two dotted lines. So there are a couple different ways that we can attack this problem. The first way that we can attack this problem is kind of the way that we did it earlier in the year, is that I can create two right triangles. So here's one right triangle, and we can find these distances. And then here's another right triangle. If I just draw this line straight down and then over. So you can find these distances using right triangles, essentially. So we're going to go through that really quickly because we've done a few of these throughout the year. The first thing is I can find the distance from A, which happens to be -5, 6. So I have a height of 6 here. It's going down to 2. That means my total height of this piece is 4. I go from -5 over to somewhere, and we're going to call this length x. And if that's x, then I know that the whole distance goes from -5 over to 4. So that's a distance of 9 total. So this here would be 9 minus x. And then the height here from B to 2 is, B is at 4, 8. So I go from 8 down to 2. That gives me a height of 6. I can now write my distances based on x and then minimize that distance. So this would be the square root of 4 squared plus x squared. This would be the square root of this thing squared, so 9 minus x squared, and then that height was 6, so plus 6 squared. And I write my function by just adding these two together. So if I just add these two things together and then minimize it, my function looks like this. 4 squared, which is 16. You don't have to simplify it. You can just plug it in like that if you want into your calculator. Sorry, not equals, plus. Square root of 9 minus x squared plus 6 squared. So go to your calculator, you can minimize that and find your answer just using that trace function or using the minimum function after you graph it. That's the first way. Okay? Way that we can do this is we could take this point B, we could actually reflect it across this y equals 2. And if I reflect it across that, it's going to go straight down. We go straight down 6 to get to y equals 2. So we have to go down 6 more to give us the reflection. So 1, 2, 3, 4, 5, 6. That gets us to -4. That makes sense. This is B prime. It's B, but just reflected. So that gets us to 4, -4. So what we're going to do here is we're just going to draw a straight line, and we're going to figure out where this point is that crosses. This part makes sense to me intuitively because we know that the shortest distance from A to B is a straight line, and these two triangles are going to be exactly the same. So, you know, it kind of confirms that we can use this method. Here's my actual point P. I know my P before was an estimate. I just kind of guessed and plotted it and used x's and 9 minus x and all that other stuff. So this point right here is going to give me the actual point P. So I know that P is on y equals 2. I just need to write the equation of this line. Okay, so the next thing that we need to do is we need to find the slope of the line from A to B prime. So B prime goes from -4 to 6. So that's -4 minus 6, the slope of A to B prime. That's -10. And the top of our slope, the run is from 4 back to 9, so 4 minus a -9 gives me a +9. So my slope of a to b prime is negative 10 ninths. I also can plug in either one of these points. Neither one's going to be easier than the other, so I'll just pick the first one. Negative 5, 6. So y minus 6 equals negative 10 ninths x plus 5. So I now have the equation of this blue line here. Maybe I should turn that blue, just so we can match stuff up. But I've got two equations of the lines, actually. And remember, what I'm interested in finding is actually this point right here. It's the point that's on the line y equals 2 that is closest, or that makes this distance the shortest. So I've got a system of equations. All I really need to do is plug in 2 for y. And that looks something like this. I'm going to pause the video and solve it real quick. You can do the same. I'll show my work off to the side. Off over here, but we'll find our x coordinate. So negative 7 over 5 is equal to x. That's the x value, and that makes sense. It's a little bit left of negative 1. Plug that back in and you'll get your y. Actually, we don't have to plug it back in. We know the y is 2. It's on y equals 2. So our solution then is negative 7/5, comma 2. That is the point that's going to make the shortest distance from A to B prime, or from A down here and then up here.